Let's start this talk with an analogy. Um, it all started as a good love story full of hope, dreams, and a sense of endless possibility. A data scientist built a Streamlit app, proudly said it works on a laptop, and then hands it over to MLOps or ML engineer. And then ML engineer takes a quick look at it and see security holes, massive model loading times, and quickly realizes this relationship is toxic. So it turned into, claims and whispered curse at 2 a.m. during the debugging. But fear not, today we will try to bring this gap and make the relationship functional again. And you will hear about how to overcome disconnections when you are trying to deploy your app from your laptop to cloud. So our agenda is first I will talk about briefly what it was Streamlit, why do we need it, and then we will go over different disconnections like model loading, auto-scale and authentication, security, sensitive CRED storage, and maybe happily we will have a happily ever after and happily Q&A. My name is Darya. I guess I can skip this part because I had a very nice intro. So first question, how many of you have heard about Streamlit? Yeah, okay, once you came here. And how many of you worked with it, touched it? Yeah, pretty many hands off. So yeah, I will just keep this part simple and brief. Streamlit is an open source Python library to create and share custom web apps for machine learning and data science. So why is it good? Why is it popular? Because you can have a quick way to show your models or your data to stakeholders. It has very simple functionality to use to quickly start building. And even if you're not working with external stakeholders, it's an easy way to test your models. And if you, like me, cannot write a backend and front end, it can be a lifesaver. And also, it has a lot of predefined elements, so it's hard to make it ugly, but I know people who managed. So let's go over to the first disconnection as a model loading. And as example, here we have a bit of Japanese here. Just a fun project, I built a Japanese learning app. So if you know a little bit about Japanese, it has a kana alphabet. And it looks nothing like our Latin script, right? And you need to memorize these characters, and there are a lot of them. So to be able to write them and to be able to quickly test and understand whether my writing is good, I decided to build the app and to recognize what I have written. I need to some OCR model which can parse the character and map it to a Japanese kana character. So I tried to use some LLMs, but they were not good enough to parse a single character. And maybe they were expecting for like whole words or whole phrases. That's why I decided to use OCR model from a Hugging Face hub, which does optical character recognition. So I have a model and I need to download this model somehow from the Hugging Face hub. And how can I approach this task? So I can write a simple function which checks whether I have a model and download this model each time in my Streamlit application and save it to a session state. Why do we need session state in Streamlit? Because every time user clicks on something, page is going to be re-rendered. So, but this means that models is actually downloaded every single time. So maybe it's not a big deal when I'm playing with Streamlit on my laptop, but you can imagine if we have multiple users, we have like a lot of pages with our application opened, and this is slowing down the app performance. User have to wait. They have to wait until the model loads, and also it increases costs. And why costs? Because I don't pay anything when I downloaded model from Hugging Face. It's free. Like, why costs? So if we take a look at a simple architecture, when we try to deploy our Streamlit to, for example, AWS or to public cloud, it may look like this. So we have our application deployed as a task running on Elastic Container Service as Elastic Container Service Fargate tasks, and we have it in a private subnet. So private subnet, it means that it doesn't touch like public subnet. It's due to security reasons. And in public subnet, we have NAT gateways. This is something that ensures that your app has outbound network connection. So if you need a model to be downloaded, the download will be handled by NAT gateway. And here is where costs come in, because okay, you need to set up NAT gateway, you pay per hour, but you also pay per gigabyte of data processed by your NAT gateways. Yeah, here you can see that it's not a big deal. It's only like $2 versus $20, but it was, just for sampling purposes. But if you imagine the scale, if we have several models and they're all like more than gigabyte of weight, and we have multiple users, that this number can grow and grow, and we can avoid it. Yeah. So we use the Streamlit cache to reuse loaded models, but we also can preload models during the image build, and maybe even the better solution would be to deploy models and call them as APIs. But the last option is heavily depend on your setup, on your company, and your MLE team. So let's try to have a golden middle. What we can do is like a data scientist. This was our previous code which we used in our Streamlit application. But we can move this code actually to a separate module, which is preload model.py. And we can have this function, like we can have this model called during the Docker container build on time. So we just run this module and we just downloading and saving the model into a separate directory. And we just check this directory in our Streamlit app. So we're just assuming that the model is there. It's being downloaded and placed into correct directory, and we can use it during our app run. So this hopefully makes the life of our ML team easy, MLOps or MLE team easy, and this disconnection is being solved. The second disconnection is about auto-scaling and authentication. And we think about when we work with AWS and we try to build something on a Streamlit, we have some different options of, let's say, deployment. First, maybe the quickest one is to try to use Amazon SageMaker Studio proxy with JupyterLab 3. Then you can use a virtual machine or EC2 Elastic Compute Cloud instance to, it's like do-it-yourself approach to host your Streamlit app there, or you can use AWS Fargate and Elastic Container Service Managed Containers as a serverless option. And in that case, the first option is not about auto-scaling, it's about like building the app and sharing maybe with your team of developers. Second option is challenging because you have one instance and you need to do maybe vertical scaling. You need to just make your instance bigger. And the third option, despite it involves more services, it actually does the auto scaling easy. So we have our app running as a containerized app using Elastic Container Service, and Fargate. Fargate does it serverless, so you don't need to manage servers, underlying service, underlying infrastructure, and you can use auto scaling based on threshold, and you can put your threshold and make it automatic, and you also can use a combination of reserved and spot instances here. So also authentication, it's kind of, you know, like boring type of task that should be done, yeah, and it's a big question who should take care of it. And one way to take care about it is to, you know, hold it over to data scientists, but they need to build everything, like login widget, the logic of authentication, privileges, so everything. And MLOps engineer they just don't care what's going on inside your Streamlit. But since we are running, for example, on AWS, you have service like Cognito, and here we have like a split of tasks. So MLOps engineer can help to create a Cognito user pool, like a user directory, then configure app client, set up domain name, and configure callback URLs where your user will be directed. So in that case, data scientists just need to have proper Cognito authentication initialization inside the app. They need to authenticate user and check the permissions. So in that case, it is becoming pretty simple for a data scientist. So they just can use credentials and can connect to the app, to the set up app by MLOps engineer, and then can inside the code check if the user is authenticated, and also depending on your business use case, if there are different roles, for example, reader or administrator. So by splitting up the tasks, hopefully this relationship became better. The next one, very important one, is security. And yeah, you see this setup. We have application load balancers that balance the load between two availability zones. So our app is highly available. We have our Streamlit app running on the serverless Fargate. It is like auto-scaled, and it seems that it's pretty good, but we can do better. Or we can use services like Amazon Route 53, Web Application Firewall, and Amazon CloudFront to enhance the security. And how does it work? So mainly there are tasks for MLOps engineer, but data scientists should be aware about them. For example, the first one, when we're setting up the HTTPS with Route 53 and TLS certificates for secure connections, role of the data scientist. So first, to be aware about the difference between HTTP and HTTPS, and inside the app, try to avoid like insecure API calling and everything that, you know, put the app back in terms of security. The second task is to configure CloudFront to protect against DDoS attacks and improve performance. So CloudFront works as a content delivery network. From one side, it protects the app from like a lot of malicious traffic, and from the other side, it has caching. So here, the role of data scientist is to understand and collaborate with MLOps engineer to establish the best caching strategy to balance between performance and content freshness. And the last one is using Web Application Firewall to block malicious traffic. So Web Application Firewall can prevent SQL injections, cross-site scripting, bot attacks. And the task of data scientist is to validate and sanitize user input inside the application. So by understanding the shared responsibility of security between MLOps engineer and data scientist, hopefully we bridge the gap between them. And the last disconnection we will discuss today is to how to store credentials securely using AWS. And in our architecture, you may have noticed that we are using AWS Secrets Manager. In that case, it has been used to store secure headers. So Amazon CloudFront uses these headers to communicate with application load balancer, and it attach the CloudFront attach the secure header to each call, which is being done to application load balancer, and application load balancer on its side checks the value of the secure header. And all the values are stored in AWS Secrets Manager to prevent their exposure. But in terms of data, if you think about this concept from the data scientist perspective, yeah, you know that we have a lot of situations that you need to do a quick check whether it's working, and you can exposure like token, creds, API keys, just forget and put them. Happily, we have a AWS Secrets Manager, and we have just 5 lines of code set up to be able to use this as a reliable and secure storage for your API for your tokens, for your credentials, for your API keys. You just need to use Boto3 to connect to AWS Secret Manager and load the secret value, and you are using environmental variables to get this value by the secret name. And yeah. So this is happily like bridging the gap, because MLOps engineer don't struggle with your secrets exposure. So happily we approaching happily ever after. So key takeaways, maybe the one biggest takeaway is to communicate. Yeah, because when you are working as a data scientist and trying to build application, you very often have no idea what is being done when the app is deployed. You just think that it's like a green button, you need to press it, and it is like magic is happening. So you need to think about problems like performance, scalability, authentication, security during the time your app is deployed. And for MLOps engineer, you need to understand that the app development can be challenging, and there are like easy and quick solutions that they can offer to data scientists, so all the compliance levels are being met. So again, yeah, communication is key. If you're interested in my Kana app that I showed you in the beginning, and if you want to have hands-on experience how to build this architecture and how to try to deploy a Streamlit to AWS, you can use my report not to start from scratch. And yeah, we have time for Q&A, right?
Thank you for the wonderful talk. And yes, we have some time for Q&A session. And the first question, how do you handle cold start delays when auto-scaling Hugging Face model in Streamlit, especially for large models that exceed Lambda's size limit?
Okay, you are talking about Lambda. Oh, okay. Cold start delays. The question, here is a question. I see that Lambda is mentioned, but it is like, at the moment it is challenging to use Lambda with Streamlit because of web sockets. So far I haven't seen any example of Lambda usage with Streamlit. It's mostly about having this containerized and with with the help of Fargate and Elastic Antenna Service. About cold start delays, I guess if you cannot like quantize your model, if you cannot like make it, shrink it, yeah, I need to think about it. Yeah, let's meet afterwards and discuss it.
What size of the image, which grows with embedding the model, has a negative impact on the performance?
Mm-hmm. Okay, so I would say that I would say that the image size, if you're working with the Elastic Antenna Service, I wouldn't put this this way. I wouldn't say that it would have like a huge negative impact on the performance. I think that it will depend on your use case and how do you set up the auto scaling and all this threshold, and also actually here the perspective of data scientist is also valuable, because you can, for example, if you have an auto scaling configured using ECS and Fargate, you can set up not only like threshold, you can set up also some kind of rules, because you can think that during business hours there are like more people are likely to use the app. So yeah, it is, I would say it is highly dependent on how you can configure the auto scaling itself.
From your perspective, is being able to fetch the secrets via the environment of your container a secure enough way of managing runtime secrets?
So I would say it is considered as a like better practice to use a AWS Secrets Manager, and yeah, so far what I've seen during the, unfortunately there are not a lot of tutorials and example projects how to actually deploy your Streamlit to AWS. But so far what I've seen, using AWS Secrets Manager is the best way to do it.
Who should be driving the discussion between MLOps and data science scientists to bridge the gap?
Both. Because it is good when you have a good product manager or, good guy in a team who can, like a team lead or someone who can set up a table and invite both teams or both people to a conversation. But I think that the key here is to maintain like an interpersonal relationship, and just to try to speak and talk to each other. I don't know whether you work remotely or in office. In office that would be easy. You just grab a coffee together and you can talk about struggles. Yeah.
Okay, unfortunately, we need to finish right now because Darya should be a Superman flying down to the other room. So if you have additional questions to Darya, please, I think you can find her. And thanks again, speaker.
Thank you. Thank you so much.